For as long as we've looked up at the night sky, we believe we understood the story of the universe, that it began 13.8 billion years ago, when time, space, and matter all came to life. But now, something doesn't add up. The James Webb Space Telescope has found galaxies and stars that seems too old to exist, objects that appear to have formed before the universe was even ready for them. If that is true, it means our cosmic timeline, the one we've trusted for decades, could be wrong. In this video, we'll uncover how Webb's discoveries are shaking the foundations of cosmology, challenging what we thought we knew about the Big Bang, time, and the true age of the universe. If you're fascinated by deep space mysteries, by the questions that rewrite science itself, make sure to like this video, subscribe, and join me on this journey through the cosmos, because what Webb has found might just change how we understand the beginning of everything. The universe has a clock. It started ticking 13.8 billion years ago when time, space, and energy burst into existence in a moment we call the Big Bang. Every star, every planet, and every atom has followed that same ticking ever since. For decades, that number 13.8 billion has been one of the few constants in cosmology. It's the age of everything, or at least it was. Now, new data from the James Webb Space Telescope has introduced a paradox. Webb has found stars that appear far too old, far too evolved to fit inside that number. If the data are correct, these stars shouldn't exist. They seem to have formed before the universe itself was ready to form them. Some appear to have already aged billions of years by the time the first galaxies emerged. It's a discovery so strange that even scientists are cautious about what it might have mean. Because if Webb is right, our cosmic timeline is wrong. And if our timeline is wrong, then our understanding of the universe's very beginning may have to be rewritten. The question is simple, but the implications are not. How can something be older than time itself? How can stars exist before the universe gave them permissions to shine? To answer that, we need to look closely at what Webb actually saw. The James Webb Space Telescope was built to see the earliest light in the universe. Its massive gold mirrors and infrared detectors were designed to peer through cosmic dust and distance to find the first stars. And almost immediately after it began to collecting data, it started breaking the rules. Astronomers expected Webb to find small, faint galaxies at the edge of time. They imagined dim clusters of newborn stars still struggling to ignite. Instead, Webb found fully formed, mature galaxies appearing just 300 million years after the Big Bang. These galaxies were enormous, bright, and surprisingly organized. Some contained as many stars as the Milky Way, even though the universe itself was still in its infancy. It was as if the cosmos had skipped childhood entirely and gone straight to adulthood. But buried in that light was something even stranger. When Webb analyzed the spectra of those early galaxies, it found signatures of ancient stellar populations. Stars that appeared to have been burning for billions of years, before the universe was old enough to allow them. This is what scientists call the cosmic age problem. It's not the first time it's appeared in astronomy, but never before has the evidence been so direct. Webb's data suggests that some stars might not fit inside our current timeline at all. The first hints came from a series of deep field surveys, including JWST and Cosmos-Webb. These programs targeted regions of the sky so distant that their light has been stretched almost beyond visibility. Yet, Webb's infrared sensitivity allowed astronomers to decode those ancient signals in unprecedented detail. Among them were galaxies whose stars showed the distinctive fingerprints of heavy elements like carbon, oxygen, and iron. Those elements don't appear in the first generation of stars. They are the product of previous ones. So to exist this early, some earlier generation of stars must have already lived, burned out, and died. That means that by the time we see these galaxies, the universe had already gone through multiple generations of star formation, and that simply shouldn't be possible within 300 million years of the Big Bang. The math doesn't fit and the physics doesn't agree. Scientists began to double-check everything. They recalibrated Webb's instruments, confirmed the redshifts, and reanalyzed the spectra. But every result pointed in the same directions. The stars really did look ancient. It's not just one galaxy either. Webb has now found dozens of similar cases, each showing signs of stellar population that shouldn't yet exist. And the more we look, the more of them we find. So how do we make sense of this? There are a few possible explanations, and each one challenges something fundamental about the universe. The first is that our model of stellar ovulations are incomplete. Every age estimate depends on how we think stars burn, cool, and change over time. But those models are based on modern stars, ones with metals and stable fusion processes. The first stars made entirely of hydrogen and helium might have evolved differently. These so-called population 3 stars were massive, short-lived, and extremely bright. They could have aged rapidly, collapsing into supernova and seeding new generations, far sooner than expected. If Webb's ancient stars are descendants of these early giants, did they only look old because they inherited that early complexity? Another explanation is that the universe itself might be older than we think. That number, 13.8 billion years, is not carved in stone. It's derived from measurements of the Hubble's constant, the rate at which space expands. But astronomers have found a persistent mismatch between how that constant is measured nearby and how it appears in the distant universe. This is called the Hubble tension, and Webb's data is widening that gap. If the expansion rate is slightly slower than we think, the universe could be several hundred million years older. That extra time might be enough to explain the paradox. It will mean stars predate the Big Bang. It will mean the Big Bang happened earlier than we've calculated. And that possibility is beginning to look more realistic with every new Webb observation. Even so, there's another layer to the puzzle. Webb has also found supermassive black holes, millions of times heavier than the Sun, existing when the universe was less than 400 million years old. Just like the stars, these black holes shouldn't have had enough time to grow that large. If both the stars and the black holes are too mature, it suggests the early universe evolved far faster than any of our simulations predict. The physics of those first few hundred million years might have been very different from what we'd assumed. Perhaps matter clumped quickly or dark matter played a stronger role in the earliest structures. These are not minor corrections to the model, they are fundamental shifts in how we understand time itself. Because if stars appear older than the universe, then either the stars are lying or the clock of the cosmos is. The universe has never been known to lie. Astronomers began looking for clues closer to home. If Webb was finding impossible stars at the edge of the universe, maybe the same paradox could be seen right here in our own galaxy. And sure enough, the pattern emerged again. Using Webb's near-infrared imaging, scientists turned their attention toward globular clusters, ancient, tightly packed spheres of stars orbiting the Milky Way. These clusters are some of the oldest known objects in the cosmos, long believed to have formed shortly after the Big Bang. But Webb's precision instruments revealed something astonishing. Some of the stars within these clusters appeared older than previously calculated, older in some cases than 13.8 billion years. The numbers didn't make sense. How could stars in our own galaxies predate the universe that contains them? At first, astronomers thought the answer was calibration error. Perhaps the models used to determine stellar ages were slightly off. But as Webb's data accumulated, the discrepancy persisted. Everywhere, the telescope looked across distant galaxies, nearby clusters, and even in faint stellar populations, the same message echoed. The universe seems to contain things too mature for its supposed age. The cosmic clock appeared to be running behind reality. To understand how this could happen, we need to look at how the age of a star is determined. Scientists study a star's color, temperature, and luminosity, placing it on what's called a Hertzsprung-Russell diagram. From there, they can estimate how long it's been burning hydrogen in its core. Young stars sit on the main sequence, bright and blue, radiating with energy. Older stars drift toward the red, dimmer, and cooler as they burn through their fuel. It's a reliable method, at least for stars we can study up close. But in the distant universe, it becomes trickier. Light has been traveling for billions of years, stretched by cosmic expansion and warped by dust and gas. A single misjudgment in how that light behaves can shift an age estimate by hundreds of millions of years. That's one possible explanation that these stars only appear older because their light has been altered on the way to us. Maybe we're looking through cosmic mirage, seeing age where there is none. But Webb's instruments are built to correct for that very distortion. And so far, the data remain consistent. Another idea points to metallicity, the abundance of elements heavier than hydrogen and helium. Stars with low metallicity evolve differently, and many of Webb's ancient stars seems to lack those heavier elements. That could mean they are truly ancient, forged from the primordial material of creation itself. It also suggests that star formation began earlier than the Big Bang model allows. Perhaps within 100 million years of time's beginning, the first packets of hydrogen were already collapsing under gravity. In cosmic terms, that's like forming mountains before the Earth has even cooled. The deeper Webb looks, the clearer it becomes that the early universe was not a calm, empty void, slowly building structure. It was a furnace, chaotic, bright, and alive, with creation far sooner than expected. In that furnace may be left behind the fingerprints we now mistake for age. Still, some researchers believe there's a deeper issue at play. If our measurements of the universe expansion are wrong, then all our age estimates are built on shaky ground. This is the heart of the Hubble tension, a cosmic disagreement between two ways of measuring time. When we measure expansion locally, using a supernova in nearby galaxies, we get one value for the Hubble constant. When we measure it from the early universe, using the cosmic microwave background, we get another. The two numbers should match, but they don't. The difference is small, just a few percent, but across billions of years, that difference compounds, shifting the universe's age by hundreds of millions of years. It's enough to explain why some stars seem to break the clock. If the universe is actually older, they say, 14.2 billion years instead of 13.8, that extra time gives everything more breathing room. It allows the first stars to form, evolve, and die before the galaxies we now see came into being. It will make the impossible possible again. But for that to be true, something in the standard model of cosmology must be wrong. Perhaps dark energy doesn't behave as we think. Perhaps gravity changes subtly across cosmic time. Or maybe, just maybe, the Big Bang wasn't a single clean beginning. Some physicists have begun to wonder if time extends further back than when we can measure. If our universe is just one phase in a larger cosmic cycle, a rebirth rather than a beginning. It's an idea that sounds almost philosophical, but it arises from the data itself. If stars appear older than the universe, perhaps the universe has simply lived longer than we've realized. Perhaps it remembers an age before our own. For now, Webb continues to collect evidence, turning its gaze toward regions where the earliest galaxies glow faintly through the cosmic fog. Each new observation sharpens the paradox instead of solving it, and the more we look, the older the universe begins to feel. Astronomers are cautious, as they always are. They know that extraordinary claims require extraordinary evidence. But they also know that every time we've reached the edge of understanding. The universe finds a way to push that edge further. Maybe the stories Webb has found aren't really older than the universe. Maybe they're simply older than our ideas about the universe, and in the end, that might be the same thing.